Hello, grade 9s. We are finally starting our new unit. And to do that, we have to go all the way back to grade 8, all the way back to the beginning of grade 8, when we talked about something called the particle theory of matter. Now, if you remember, this theory of matter, it had 5 things that it told us about matter. Matter is the material that makes up everything that we see. It is the gases in the air, it is the water in the Arctic that's frozen, it is our plants, it is our animals, it is our food, it is our metal, it is the materials that make up your phone. Matter is everything. And the particle theory of matter is a way to look at what that matter is. So we have 5 points. And while I'm talking about this, the section that I'm talking about is this first part here on your workbook. We're going to aim to address those 5 things. And the first one is the simplest of all of them. It says that all matter is made up of tiny particles. Everything that we see in the world is made up of particles that are too tiny for our eye to see. And we use things like microscopes and other technologies to look at those very, very magnified and tell us about some of these other properties. Now, that was A, and it said that all matter was made up of tiny particles. Number 2, or B, 1B, says that each pure substance has its own kind of particle, meaning that not all particles are the same, and that something is made up of its own type of particle. So each pure substance or each basic particle makes a different thing. So what you can actually write down is that each pure substance has its own particle. More on that later. More on that later is our whole unit. C. Particles are attracted to each other. If you've heard of a fun thing called gravity, this is the basics of it. Is that matter, those tiny little things, are attracted to each other. And when there's a whole bunch of them together, you get some different types of attraction forces. D. Particles are always moving. Even in solids, even in things that are hard and you can't see them moving with your own eyes, the particles inside, those tiny little things are always moving and in motion. E. Particles at higher temperatures, so something that's hotter has those particles moving faster than something that's colder. So the more you heat something up, the faster those particles move inside of them. All right, this is really important that we get this because this is the basis or the basics of all of our units. So if you need to rewind and look at those or this part of the video again, please go ahead and do so. And I'm going to add a couple of videos that talk a little bit more about that as well. This next part here is taking the rules that we learned up at the top and applying it when we think about gases, liquids, and solids. Now we're not talking about, say, the air around us versus the water or orange juice in our fridge versus the solid phone that you have. When we're doing our comparison for this next part, we're talking about comparing one thing that is in the different states of matter. That would be like saying, if we looked at water, in our gas form we have steam. In our liquid form we have water. And in our solid form we have ice. The degree of attraction between particles means how closely those particles like to be pulled towards one another. And we get a pattern that says, so if you're just looking at this part here, as we go from a solid, a liquid to a gas, you can agree, if you just think about water, that gases are, you'd have to be the warmest for it to be a gas, medium, and then the coldest for it to be a solid. So how much they're attracted between particles, we see that as a solid, they are the strongest attracted. That's why they stick together and make that solid ice thing that isn't flowy and things like that. So the degree of attraction between particles is strongest, somewhat strong, and weakest. Strongest, somewhat strong, and weakest. All right, let's move over to our next one here. Volume. Volume is how much space something occupies. And it's a little bit different to think about. It's not as much a less, more, more, like it was with talking about the attractions between particles. When we talk about volume, meaning does it take up the same amount of space, or can it change? And we can't change the volume in a solid or a liquid, but when we get to a volume, if you think about if you held a balloon in your hand, you're holding all of the gas in there, you can actually change the amount of space it occupies by pushing it. You can compress it. And that's what we talked about in grade 8. So what you can write here is that it has a definite volume, and then a not definite or a not certain volume. And lastly, shape. And shape is probably the easiest to think about. It's basically asking, can it flow or not? The shape of a solid is definite, meaning it will not change. You can break it apart and do that, but the actual shape of it, without you doing anything to it, will stay the same. A liquid, you can pour and it can flow and it will change the shape. It will fit to whatever container you put it in. That is the same thing that happens when we think about our gases. So whenever we look at these different things, the volume, the shape, the degree of attraction, that's what we've just talked about. But when you think about why, before you continue on with your worksheet, I want you to remember back to grade 8 and think about how these different parts of our particle theory of matter, how they affect the why for the answers that we just got for this section here. Now for today, you need to follow along with your textbook. I'm going to give you the rest of the day here to finish this part here and your next sheet right on here. And we'll move on tomorrow. Please, 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 if you have questions, please contact me. You know my email address. It's on the website and it's been handed out. Please contact me. I do look forward to hearing from all of you, and I hope that you're doing well. See you tomorrow, everyone.